Section 6 of Chapter 7 is included in our curriculum, so we'll be doing solving radical equations. As in the previous section or chapter, we said there were expressions which we simplified, and then there were equations that we solved. Here we're going to solve equations. And we're going to use to solve equations the principle of powers. So these are equations, and since they contain radical signs, they're called radical equations. Now, what is the principle of powers? Well, again, getting back to our old concept of an equation, that what is on one side is equal to what is on the other side. If we raise one side to a particular power, and we raise the other side to a particular power, the same, we have maintained equality. Now, there is a problem every once in a while that we generate an answer because we're squaring something that is not a valid solution. So we have to be careful of that when we use the principle of powers. So let's go on. And that's what they're describing here, by the way. Interactive discovery. If x equals 3, does x squared equal 9? Yes, so that's true. If x equals a negative 2, does x squared equal a 4? Yeah, that's true too. If the square root of x is 5, does x equal 25? That is, if you square that, and that is true. If x equals a negative 3, and if you square a negative 3, does that equal 9? In a sense it does, but remember, we're saying, can we have this? Like that, we can't have it. But if we have this, then we have it. So this one is the iffy one here, okay? Something to think about anyway. And here they're saying for every solution, x equals a. If the solution is of x squared is a squared, but not every solution is this, that sometimes you can get what is called an erroneous solution. That is, it's not true. So we have to be careful and try our answer in the original equation. That's one of the little problems with this, as we mentioned, the power rule. So let's go on. Now, here in solving these, we're going to develop a technique. Now, the technique is to get all of the terms over to one side and keep the radical. We are going to isolate the radical. So this then becomes the square root of x equals a 7. Now what do? Well, now, whatever the index number is, even though it's not there, is a 2, we're going to raise this to the second power to get rid of our radical sign. Then we have to do it to the other side. So we then get x equals 49. Now, if we put a 49 there, the square root of 49 is 7. 7 minus 3 is 4, and this checks out very well. Okay? Again, we're starting off very easy. All right, let's do this one. Now here, we're bringing this over, and we get the square root of x all by itself is now equal to a -2. Now again, we're going to raise this to its index number. That just gives us the radicand, and we get 4. Now, when we put our 4 back in the original equation, the square root of 4 is 2. 2 plus 5 is 7. So that is not true. So by having the square root of something equal a negative, that's going to generate one of these erroneous roots. So we say then, for this, there is no solution. The number 4 does not check. Thus, the square root of x plus 5 equals 3 has no solution. So you have to be careful on these. Again, raising both sides of an equation to an even power may not produce an equivalent equation. In this case, a check is essential. These are not equivalent. And the key is that you had the square root of something equals a negative. That's sort of a hint. Okay, let's get on to something a little more in line of what we'll be doing here. So it's to solve this. Well, here, what you want to do is to bring this 5 over to the other side, and we get then x minus 5 equals the square root of x plus 7. We have isolated the radical, bringing this over to the other side. Now, we want to get rid of the radical sign, which has a 2 there. So we're going to square this, and we square this. Now, a little shortcut here, squaring anything that has the same index number as our exponent just gives us the radicand. So with the 2 there, remember putting that 2 under, you take away the radical sign, you just get the radicand. Now we have to square a binomial here. I'll use that special technique. We have a quadratic equation. I'm going to integrate. This comes over as a -1, so 11x. This comes over as a negative, so I get an 18 equals 0. And we're right here, by the way. Now, we're going to factor, because that's the only way we know so far. Next chapter, we find out different ways. And our sign needs to be both negative. So here x equals 2 or x equals 9. Now here again, since we have squared something, we may have introduced an erroneous solution. So how do we find out? Well, we have to check our answers. In the original equation, the 9 works. But in our original equation, the 2 doesn't work. So even though you got these two as possible solutions, think of it that way, you have to really check them to see which ones will work. So if you put both in MATLAB, they're going to count that wrong. You have to check them and put only the 9. Okay. All right, let's take a look at this one here. Again, it's all worked out in your book, but I want to help you with the strategy. Now, what do we have to multiply? Well, first we have to bring the 5 over. So this is going to be a negative 5 on this side here. Now, this is actually, in a sense, the third root of 2x plus 1, right? Equals a negative 5. Now, you might get nervous seeing that it's negative, but since it's the third root, that's okay. Now, they're doing it this way. Another way would be this way. What do we have to multiply this by or raise it by to get rid of the radical sign? And the answer is a 3. Well, interestingly, that's what you have to multiply this by, because this is a 1/3. You're going to multiply that by a 3. And again, exponent of 3. So now notice what happens. These just cancel out, and we end up with our radicand. And this is going to be a negative 125. So they have it right here. So now we transpose that. We get 2x equals a negative 126. Divide both sides by 2, and we get x equals a negative 63. And if you put a negative 63 in there, that works out very well. Okay, the check is below. And it is true. Okay? Now I do work some of these out on the additional exercises and on the test that I have posted for chapter 7. Let's get the right chapter here. Okay. All right, let's take a look at this one now. Again, what is the strategy you're going to use? Well, the key is you want to isolate one of the variables. And this one is isolated already, and this one has a 1 there, so that's okay. And then the rule is get rid of one of the variables, or one of the radicals, by squaring both sides. Now, when this is squared, that is raising it to the index number, it just becomes the radicand. So we get 2x minus 5 equals. Now here, this special technique of squaring this is going to be very useful. We square that first term. That just gives me a 1. We multiply these two terms together, double it. So this will give me a plus 2, the square root of x minus 3. Now, again, squaring this just gives us the radicand, plus x minus 3. And you'll see that's what they've done here as well. Okay, so let's combine like terms here. Here we don't have a lot of like terms on this side. Here we have a 1 and a negative 3. This is going to give us a negative 2. It's going to give us a plus x. And then we have a plus 2 and this here, the square root of x minus 3. Okay, so I'm going to bring this x to the other side, and I lose 1x, so this just becomes x here. I'm going to bring this to the other side. It becomes a positive 2, so this becomes a negative 3. And now I have 2, the square root of x minus 3. Okay, so what I've done is, again, reviewing. This is sort of tedious. Raising this to the second power just becomes the radicand. Use the special squaring a binomial technique to get this. And we then squared this and we got that. Okay. Then I kind of combine like terms. I had a 1 and a negative 3. Gave me a negative 2, and I have a 1x there that I moved in front. So I subtract an x from both sides, and I added 2 to both sides. I now have that. So what do I do now? Well, I have to square this and square this side. So this I get x squared minus double that, 6x plus 9. That's a perfect square trinomial from chapter 5. And now this. So I square that and I get a 4. And I square that and I just get x minus 3. So squaring the 2, I get a 4. Squaring this, I just get the radicand. Now I multiply through. Let me just do that over here. So this is going to be a 4x minus 12. Now I'm going to integrate that positive 4x to this side. So I get x squared. Now this is my 4x that I'm going to integrate, gives me a negative 10x. And this negative 12 becomes a positive 12. So this gives me a 21. And that equals 0. Again, the work is all down below, and I've reviewed it. If you want to go back and review it, just rewind the tape. So now I have to factor this, because it's a quadratic. X, 7, 3, minus, minus. So here, x equals 3 or x equals 7. Now the key is, do they both work in the original equation, or does only one work? All right, let's go on, because they have it all worked out for us here too, so that's what I like about the book. And the possible solutions are this: both the 7 and the 3 check in the original equations, so therefore both our solutions. Now they're giving us a little caution here. Let's read this. Okay, they're just saying that when you do these, to get a solution, you have to square this and include the 1 when you square it. And again, that involves a special kind of squaring that you need to really become familiar with, because we're going to use that in chapter 8. Okay. So here they're giving one in function notation, where they're saying that this is going to equal 2, and that's just what you write it as. Now, how do you do this? Well, I could write it out, but if you were just reading the textbook, and we'll just follow this one, the strategy would be to take this, move it to the other side, transpose it, so now it becomes plus. Then you're going to square both sides using that special, this just becomes the radicand. Here we're going to square this, this gives us a 4. Multiply that, double it, it gives us this. We're going to square this, it just gives us the radicand. We're going to combine like terms. And here notice that when we take away the parenthesis, this x and this x just cancel out. So we have I had to look that over here, we have a 4 and a -7 will give us a -3. Okay. Now we're going to take this -3, transpose it. That gives you a +3 and a 5, give you an 8. Now another little shortcut is when you have something like this, divide both sides by 4. They're not showing you this step, and you get a 2 equals that. So now when you have made it very simple, square this, square that, you get x equals 11. And that does check. Okay, again, some of these can be quite tedious, as in chapter 6, and the slightest little error will give you the wrong answer, as you probably know. Give it your best shot. Again, the key is writing out your steps in a neat, logical way so you can possibly go back and check to see where you might have made an error. And then developing your skill so you don't make them, if possible. Okay, here is your exercise set. Again, I worked out a lot of these exercises in additional exercises that I have posted to our YouTube site. You want to keep working on your practice and quiz bees to earn your mastery. We have one topic left that's official in chapter 7. I will take a look at this next topic and see if I want to do an extra credit on this one.